So let's consider the forces acting on the reciprocating parts of an engine. The first force is piston effort. It is basically the net force acting on the piston or cross pin. Now let assume this is our piston. This is our piston. Okay, this figure. This is the piston effort, which is helping the piston to move along the line of a stroke. Other forces acting on the piston, for example, the weight of all the reciprocating components. Say if WR is the weight of all reciprocating components, including piston, cross pin, or guzzle pin, etc., all the devices which are connected with the piston having the mass mr and their weight is WR. So if WR is the weight of reciprocating parts along with the piston, mr is the mass of all the reciprocating parts. We know that the acceleration of piston is given by this relation which we are derived earlier, and by multiplying this acceleration we can find the inertia force given by this equation. Fi is equals to mr into ar, where mr into omega square r into in bracket cos of theta plus cos of 2 theta by n. This is the basic relationship of acceleration. Acceleration is multiplied the mass of the reciprocating component, and we will get the value of inertia force acting on the piston. Now the inertia forces acting on the piston are Fi, and the net load on the piston, which is due to the pressure of the gases or steam inside the cylinder. In case of double acting engine, there definitely at both sides of the piston there are some steam present. So in case of double acting reciprocating steam engine, we will find the pressure by this relation. PL is equals to P1 A1 minus P2 A2, which is the difference in the pressure. At the here the pressure is P1 and here the pressure is P2, and here the connecting rod is also attached, so the area is reduced by A1 minus A, whereas the A is the cross section area of the piston rod. Okay, since here is the rod attached. So in this way you can find the load force on the piston. Net force on the piston is basically FL minus or plus Fi. This minus plus, when the piston is accelerating, then it is a negative sign, and when the piston is retarded, then the inertia force is helping to the movement of the piston, and we will take positive sign. So for positive value of inertia force, negative value of inertia forces when the piston is accelerated, and when the piston is deaccelerated or retarded, then we will take the positive value of Fi. Now in both the cases you can also add or also subtract the frictional resistance component if given there. If the friction force is given, then you can calculate Rf here, and if P is the net pressure, then the load on the piston is pressure into cross section area of the cylinder. The net piston effort is also calculated as this relation, where in case of vertical engines the weight of reciprocating components are also acting along the line of a stroke. Okay, in this case the weight is also supported or resisted the motion of the piston. For example, at the downward motion condition, the weight supporting the piston, and at the upward motion condition, the weight opposes the piston. So at the time of acceleration of the piston, when there is a downward motion, the weight is supporting, so taken as positive, but the inertia forces are taken as negative in this relation. using this relation, we can determine the effort on the piston, net effort on the piston, because of which it is moving along the line of. Now the next force is the component of piston effort along the connecting rod. So force acting along the connecting rod. See, we are simply determine the component of Fp along this rod. If Fp is resolved along this direction, so Fq is equals to Fp by cos of phi. So Fp is equals to Fq cos of phi. So component of Fq is balancing the force Fp along the line of. So this is the force in the connecting rod. Now, if this connecting rod force Fq, which is connected to the piston pen at this point, it has two components. One is normal to the axis of the cylinder, and second is along the axis of cylinder. This along the axis of cylinder is a force which is trying to pull the piston along the line of a stroke, definitely, which is equal to the net piston effort. So the component of Fq along the line of a stroke, Fq cos of phi, gives me the piston effort. So the relationship between the Fq and piston effort is this. Now this component, which is normal to the wall of the cylinders, is called as normal reaction or the thrust force. Okay, so thrust on the side wall of the cylinders are basically the vertical component of Fq, which is Fq sine of phi. Fq sine of phi given here. Relation Fq is replaced with the help of piston. This piston effort is directly calculated using the acceleration forces, weight components, and the pressure forces inside the cylinder. So Fp is calculated easily, and using this Fp, we are calculating all other force components. Okay. Now crank pin effort. So finally, the force transmitted to the crank pin is called as crank pin effort. Okay. So the crank pin effort, if this is the connecting rod force, and the force is transmitted here, one is perpendicular or along the crank, and second is tangential to the crank. Okay, one is along the crank and second is tangential to the crank. Now this component of Fq, which is tangential to the crank, normal to the crank, is called as crank pin effort, and which is along the crank is called as crankshaft bearing force or thrust on the crankshaft bearing. So this is the relation for tangential component of this. If this force Fq makes an angle with this crank direction as theta plus phi, so the component along this direction is cos of theta plus phi of this Fq, and the component in this direction is sine component. So here I am taking the sine component, and here for bearing efforts I am taking the cosine component. Similarly, the rotational effect is created by this tangential component. This tangential component try to rotate the crank about the crank pin axis. So the movement developed by is Fp into R. Is simply basically Ft into R, because Ft is represented in terms of Fp, and Fp into R is calculated written here. Okay, so in this session we completed all the force analysis of reciprocating parts of an engine. In next class we will solve a problem based on this topic, and we will also see the turning movement diagram, which is started from this turning movement or the crank efforts or the torque on the crankshaft, which I get from the complete force analysis. If you have any doubt or query related to this session, you can contact us. Thank you.